All right. So just again, ANOVA measuring 3 different independent groups and whether or not their group means are different or if they're equal, right? So we're going back to hypothesis testing, null hypothesis testing. And similarly to t-test, this takes it a step further by looking at 3 or more groups and looking at the variation of the variance and the variation of the group means from each other across many number of groups. So t-test, 2 groups, ANOVA, 3 or more. 3 or more. Once you hit 3, sky's the limit, okay? So you might be asking yourself, why did we not go straight from t-test to ANOVA? Anybody want to take a guess? Or make something up?
I mean, can you do that in, can you do the t-test? Of course you can do the t-test in SPSS. I don't know. I'm kind
Let me
of,
blow your mind for it. Yeah, go ahead.
this note's I'm thrown off by the first bullet, which is 3+ populations means where, like, where the means are equal, where the means of each of those populations are all equal. Like, I'm confused by that sentence. Sorry.
Okay. Yep, you're good. So
Sorry.
go ahead, Mamta. No, go ahead, Mamta.
Is it because t-test can only do 2 variables and we have to use more than 2 variables, then we can use ANOVA?
Yeah, that's right. I mean, that's the main difference. But I will tell you all this, and not to break your brain, but you can run analysis of variance on 2 groups, right? And examining the differences between their 2 group means, and it gives you the same results as the t-test. Okay, so because it is essentially just 2 groups. So, but Chris, to your point, we're going back. This is what I was trying to get at when I said we're going back to hypothesis testing. Hypothesis testing assumes that all of our averages or group means, population means, whatever you want to call them, group means, are equal, right?
Oh, now I'm reading the sentence better. I wasn't reading it right. It's the test if those 3+ populations means are equal. We don't know that. Okay, I was like, how would we know that? That's what I was wondering. And then I was like, I kept reading it, and I thought population, like the word where was missing, but that's not at all what you were saying. I'm on track now. Thank you.
Cool. So as an example tonight, the one we're going to work through as a group in class, I'm going to give you an example again to work on by yourself or with each other, but the one I'm going to walk you through is looking at IQ scores from students across 3 different schools. And just as it's just a simple example of, is there a difference between, the average IQ across the 3 schools, right? So 3 groups, 1 measure, the same assumptions that we used in t-test, multiple regression, all that comes back here too, right? What are those assumptions? Independent observations, right? Homogeneity of variance, right? Linearity, right? Remember those, they're coming back. All right, so here's a quick little diagram. So school, whatever. I suck at PowerPoint tonight, y'all. I should just go back to work, I think, because I forgot to update some. As you can tell, I was building it as we're teaching it. So there we go. School A, school B, school C. And essentially measuring the IQ scores of each, independent observations. Students are not into more than 1 school. So the first step in this process, because we are talking about means, averages, group differences, let's just go ahead and summarize and visualize the variables themselves, okay? Let's run descriptive statistics to know what the group mean is for school A, school B, and school C, and we can even create a chart to understand the data, right? Pretty simple stuff. For this class, this is like less than half of a bar of difficulty, right? Kara, you're not going to just crap out on me and say, I don't know what descriptive statistics are.
Well, one can assume, but
All right, so here's a chart. Here's a chart, average IQ scores by school, right? I just did a horizontal bar chart. In fact, let me first pull up the data. Look at the data. Zoom controls are in the way. There we go. All right. There we are. It's easy. Literally school, IQ, right? School and IQ. Not many variables, 30, but hey, for the heck of it, for an example, it's pretty easy. We can always do really quick descriptives in Excel, or you can do them in SPSS. Bring IQ to values, bring school to rows. There they are. We don't want the sum. Let's look at the average. 99, 112, 93. Kara's point, oh gosh, this visualization appears that there's a difference, right? Is there really? Is there statistically significant differences here, right? All right, so the next step in this process is we need to know what our null hypothesis is, which is all population means are equal, or there is no statistically significant difference in the mean IQ scores between the schools, right? The schools are the same, right? Maybe we actually let me annotate this a little bit. Let's just say we pulled 10 students as a sample from each school, right? And so we're trying to use parametric statistics to make generalizations about a population by using sample data, okay? You hear how all the words we talk about, like in the semester and last semester or whatever, they come back every time. All right, null hypothesis, there is no difference. The averages are the same. Very good. Step 3. This is where it gets a little bit more complicated. And I'm sorry to tell you this, but I'm not going to expect you to do this by hand. We're going to talk about it, and then I'm going to help you understand what it means in the output, because I want you to run it in SPSS. I don't want you to pull up Excel and put in a bunch of formulas, okay? So there are essentially three measures we're looking at here. The sum of the square differences between the groups, okay? So sum of the square differences between group A or school A and school B, right? As well as the difference from the overall mean. That's one. The mean squares is essentially the variance among the sample means. So when we have a high level of variation from average score to average score, that means that our overall population differs more so than if they were similar to each other. I think that's pretty logical, right? If you don't have variance, you don't have differences, then you probably don't have statistical significant differences. The last one is the sum of squares within. And what that means is looking at those 10 students from school A, how much variation is there in that one subpopulation? And then looking at the variation within school B and how much they differ from each other, and then the variation within school C, okay? So you're looking at relationships across schools, the average differences and variance between the schools, and then you're also looking at the variation within the schools. So think about like left, right, and top down, okay? Make sense? And we're combining all of this, Chris, to figure out if there's which one's really affecting which one in terms of young, medium, and older, right? Like, is there really a difference between those three, okay? But in this case, school A, school B, school C. All right, now we're going back to basics. right? Here are our assumptions. We have independent observations. We have normality, right? Normal distribution. But, you know, so usually smaller populations are more likely to be at risk for this type of thing. So again, if your population is big enough, generally you're okay. And then of course, homogeneity of variance. So those are the big assumptions. Everybody knows what those mean, right? Let's do it. Let's run ANOVA. So in fact, this data file and your data file for tonight are both in Canvas now under week 13. Go ahead and download both of them for me.
You want to download both of them?
Yeah. So Chris, the reason I'm saying yes is, one, you can always use this example later on if you want to, you know, and also the one that y'all are going to do next in class is also out there. So yeah.
Oh, okay. Uh-oh. Oh no. Okay, it went down. So I got an error. It says error while processing, but it downloaded. Hopefully.
Everybody good? Okay. Let me get over there and then we'll do it. All right, so analyze, going back to comparing means. Remember the t-test, right? Going back to comparing means, but we're doing the one-way ANOVA. All right, one-way ANOVA. Analyze, compare means, one-way ANOVA. Next, our dependent variable is IQ, right? So move IQ into the dependent list. And school is our factor or independent variable, right? Notice you can only have one independent variable here, but there's 3 schools. So only one factor, right? But that factor or that variable has multiple categories. Make sense? Okay. All right. And so what we're going to do now is under the post hoc test, we want to select the Tukey one, not because I'm trying to be funny and be a little Tukey right now, but like this is essentially the one that tells us which relationships are different from each other, like which of those school A versus school C, school B versus school C, kind of which one of those are actually statistically different in this analysis. We're going to get that deep into this, okay? Okay, so Tukey. So you select Tukey. And then under options, I may not have put that. Nope, didn't put that. But anyway, it's on the recording. I always select descriptive as well as the homogeneity of variance. And if you want to, you can do a means plot. It's actually a line chart. I wish it was a bar chart, but it's a line chart. So whatever. Continue. And then Chris, this week, we can press paste. We are not using the process tool, so we can paste it if we want to. All right. Okay. Hit OK or paste. And here's our output. So what we are doing with this analysis, with an ANOVA test, is we are measuring how likely the population means are to be equal, right? How likely is it that they are equal? You know, are there differences? And remember, we talked about the mean squares between, the mean squares within, right? Those sort of things a couple of slides ago. If we don't have variance between the sample means, and we don't have any variance within our sample, let's just say everyone from school A has an IQ of 100, right? There's no variance within our sample for that school. These are the 3 things that affect ANOVA the most, right? Variances between the samples. So let's just say the average score for school A was 100 and the average score for school B was 100. There's no variance there. They're the same, right? Thus, the null hypothesis is true. No variance, they are equal, right? Okay. And ANOVA is a test that is affected by sample sizes. The more you've got going on, the more likely the F statistic will be large enough to be considered statistically significant. Okay? The F statistic is like the T statistic or the t-test. Okay? All right. So I did a little diagram for you. A larger variance between sample means may yield a larger F value. Okay? Smaller variance within samples will also help you get to a larger F value. So it's more similarity between the kids in school A, as long as they're very similar to each other, it's more likely that there's going to be a larger F value, a statistically significant difference between the groups. Okay? If we had every kid score 100 from school A, right? And half the kids in school B score less than a 30, and half the kids in school B score more than a 70, the average is still going to be, or whatever, I'm sorry, do the math. Now, half the kids in the school score below 80, half the kids score above 120, the average is still 100. So there's no variance between the sample means there, but one school has small variance within its sample, and one school has a very large variance within its sample, right? So all of this factors into this overall F statistic. And then once again, the larger the sample size, the more likely you're going to have a large F value. Just because it's compounding on itself whenever you do the sum of squares and that sort of thing, okay? All right. Let's look at our output. And I went ahead and put it here because it's always smaller in this, right? But you can trust me, it's the same. Here we go. The sum of squares between groups, the sum of squares within groups, and the total sum of squares are all calculated here for you. The F statistic is a 6.15, and what did I talk about when we went to the farmer's market?
P-value.
That p-value, yeah, 0.006, which is what?
Significant.
Yeah.
Yeah.
0.05. Yeah.
Yeah, less than 0.05, less than 0.01, less than 0.01. So we can say that. So fantastic. So there we go. That's how it's written. Wait a second. I incorporated the degrees of freedom into our, report out. Similarly, as we did with t-tests, linear regression, that sort of thing. The degrees of freedom is the number of degrees of freedom between groups and the number of degrees of freedom within groups. Okay? Okay. The way you calculate it by hand, just in case you want to know, degrees of freedom is the number of groups minus 1. So how many groups do we have? How many schools do we have?
3 minus
3,
1.
right. 3 minus 1 is?
2.
All right, and how many people are in each school?
There must be 28. Well, I don't know. 30. What is that? What are your hands saying? 10?
Yeah.
How do you know that?
10 students in each school.
Oh, we
We
had
can
30
talk about it.
total students. I forgot.
Oh, I thought that was some kind of magic trick.
No, 10 students in each school. So 10 students in each school times 3 schools is, of course, 30. So you take the number of observations, which is 30, minus the number of groups, number of schools, which is 3, and that's how you get 27. Makes
Interesting.
sense? Okay. All right. So F statistics 6.15, less than 0.01. Everybody good?
Okay, go back to that right quick. Okay, so we have to, so I mean, when we're explaining this, we are gonna say that the bullet 1 and bullet 2 are what we need to have in ours. I mean, we need to say that, okay,
Bullet 2.
okay,
And you're going to see a whole slide coming up, Chris, with what to say. Okay.
all right.
Yeah, we're not there yet. We're not there yet. So before we get there, wow, yay, it's statistically different. But how different? Remember, we've talked about effect size this entire semester. We measure effect size, how different are the means, by using a Greek letter called eta, ETA. Okay, and normally it's written as eta squared, right? And so these are the parameters for eta that are generally accepted. Anything greater than 0.01 is, but less than 0.06 is considered small. Between 0.06 and 0.14, medium, and then 0.14 and above, or rather greater than 0.14, is considered a large effect. There is no way that is really very easy to do this in SPSS, to calculate this effect size. So is everybody ready to pull out their calculators? Okay, it's actually a very simple calculation. It's measuring the proportion of the variance from the sum of squares between divided by the sum of squares total. Okay, you see that here at the bottom of the screen? Go back. Sum of squares between, sum of squares total. So you'll divide 1956.2 by 6250.3. Who wants to do that for me?
0.3129.
So 0.31, is that small, medium, or large? Or
Rather
Joe?
large.
Large.
Pretty large, just that. Yeah, 31% of the variance is between group variance, right? That's good. That's really good. If a lot of the variance was held within the group itself, then your group would not be very similar to itself, right? The students in that school there'd be a lot of differences in students within the school, not differences between the students at one school and the students at another school. Remember, the point here is to say there are differences between the schools. So we're measuring, yes, Kara, give me a sec. We're measuring the amount of variance between the schools by accounting for all variance in the entire model and saying there's definitely variance within each school for itself, right? And then what's that average amount of variance? Well, it's 4,294 here out of a total of 6,250. Well, that's typical, right? We're always going to have more within group variance generally than between groups. But when we get to this amount of between group variance, then that means that the schools themselves are seen to be statistically different. Kara, go ahead.
Do you ever figure in an eta for the within groups? Like, would it be the same thing? Would you do the sum of squares within divided by the sum of squares total, and that would give you the variance within the little pockets, or no?
It'd be 0.69. One minus 0.31.
Oh, yes, got it.
But no, it's not relevant. We always, because remember the purpose of ANOVA, I tried to say this, maybe I didn't say it well enough. The purpose of analysis of variance is to determine if there are differences
Between the group means.
between the groups.
Yeah.
So yeah, so no, we're not considering
Don't care.
an eta square for within. Okay.
Yep.
Cool. Does that make sense, y'all? You're hearing it multiple ways. Like you're hearing it between groups, right? Right. Okay. Good. All right. Next, we've not taken steps like this before. Next, We're on step 8, right? Trust me, these aren't difficult steps, though, right, y'all? I haven't. We're not going too fast, too far, are we?
No,
Is
this is
HS
actually a 1 bar. I think
Is
you.
HSD
Well, no.
really? I'm sorry. I'm sorry. Go ahead.
Oh, Jody would reclassify this as 1 bar. Okay.
Am I wrong? So that makes me know what's about to come up. It's about to be like 6 bars, probably. So
Oh,
He's gonna go back. He's gonna go back and change it.
no, don't. Oh, dang. Sorry, guys.
Doesn't matter.
All right. Here's the thing. Now that we know, yes, there are statistically significant differences between these schools in terms of student IQ, right? As per these samples. We also know how, essentially, how different are they, right? Are they very different, somewhat different, not very different, right? Small, medium effect, or small, medium, large effect. Now we're doing something called a post hoc test. You haven't done this before. So as I like to call out my friends from Monty Python, now for something completely different, right? This isn't really that different. It's just one more step. It allows us to say which groups differ. Because school A and school B might be exactly alike, but school C is like the shining star, right? Got the smart kids or whatever. So Tukey's, remember we clicked on Tukey, it's called HSD, and Chris, you made a comment about HSD. I don't know what HSD might allude to here, so please fill me in.
Sorry for all of that. I'm freezing cold. I need to get some blanket action going. You don't know that's what that stands for. That's your guess.
No, you said HSD, blah, blah, blah. I thought maybe it stood for something different.
Oh, different. No. Does it really, in this case, does it stand for honestly significant difference? Or are you being funny?
I'm for real.
Okay.
Yeah, it's yeah. So Delaney says, let me be honest. And 9 times out of 10, I'm just short with my, quips, and I say, please lie to me, right? But no, that's what HSD stands for. It means honestly significant difference. That's not going to be on your test. Just remember, Tukey's is the post hoc test that we run here. Let's look at it, okay? And remember, bless you, or Jody. You okay?
I'm with you. Sorry. Thank you.
Twice.
That's not fair. You got to. All right. I'm muting myself for the rest of this class.
All right. So here we go. ANOVA, right below ANOVA, is the post hoc test section that we asked for. Here it is as Tukey's, honestly significant differences, right? So let's look at it. It's looking at the initial versus the comparison school, 1 versus 2, 1 versus 3, 2 versus 1, 2 versus 3, 3 versus 1, 3 versus 2. 1 versus 2 should be the same as 2 versus 1, okay? Just different sides of the zero. Notice, negative 13.4, 13.4. I'll come back over here. Sorry, Kara. Negative 13.4, 13.4, 5.9, negative 5.9. Y'all see this, right? Where do we see honestly significant differences between the schools?
2 and 3.
3 and 2. Yeah. We said the same thing. We just said in different orders.
Yeah.
Yeah, actually, it took me a second to process it. But yeah, 3 and 2 or 2 and 3, right? School B and school C is where we see the differences. A and C and A and B do not differ significantly. But what the heck did we see at the beginning, Sarah? They look different to me, right?
Are
Well,
2 and 3 B and C?
yes, yes.
Okay,
Sorry. So
No, that's
hey,
right.
hold on. Pause. Time out. When you create these groups in your data, you have to give them numbers. Okay. They have to have a numeric value in SPSS to run. So school A is 1, school B is 2, school C is 3. Sorry.
Did you do that in the data set? Is there like a label? Let me see that, because that's where I always get all jacked. Okay, so there are numbers there and they came as numbers, but did you label them by any chance?
We can. I did not, but we can.
Okay.
So I can just do this right here and say 1 is A, add 2 is B, add, and 3 is.
Are you
Is
using
okay?
28 or the old version? Because it looks different now.
This is my version.
Okay, I just am saying, because that whole label section looks very different.
Yeah. All right, so let's run it again real quick. Boom, there you go. School A, B, C. See it? Cool. All right. All right. So now, oh, and here's our ugly line chart that shows. Yeah, it would be better with the bar chart, but SPSS doesn't assume that they're categorical, so it makes the assumption that everything's continuous, right? So point, 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 scale is all wonky, 90 to 115, so it exacerbates whatever differences there may be. All right, come back to it. So we know that there are differences, but SPSS helps us understand that there are not statistically significant differences between school A and school B, school A and school C, but between school B and C, there are statistically significant differences. So this is, again, taking it, how many steps are we at? 8 steps, right? And according to Jody, that they are very simple steps, all level 1, right, or lower. So, right, sound good? Let's write up the results in step 9. Okay, Chris? All right. Our average IQ score is different between the 3 schools. A one-way between subjects ANOVA, analysis of variance, was conducted to compare the differences of IQ scores across 3 schools. You see how I put dependent variable, independent variable in there? Go ahead, Karen.
That's what I was going to ask. Thanks.
Yep, just do, as a reminder, dependent variable, independent variable. I was trying to map it for y'all. Okay, ready? There was a significant difference between schools on IQ scores at the P is less than 0.01 level for the 3 schools. F value, right? Degrees of freedom, 6.15 is the F statistic, less than 0.01. Eta squared is 0.31, right? Got it? If there are differences in the post hoc comparisons, okay, which we know there are, post hoc comparisons using the Tukey honestly significant difference test indicated that the mean score for school B was significantly different than the school C, or from school C. However, school A did not significantly differ from school B or school C.
And where are we finding the,
What's that?
the information, the 112.6? Where is this?
Oh, yeah, good point, Jody. Remember at the beginning I said under options, right? Compare means, one-way ANOVA, options, descriptive statistics. When you do that, the very first thing it gives you is descriptive
Oh, okay.
statistics, and that's where they come from. So I'll update the slide with that option selection for y'all. Okay, apologies for not putting that on there first. Make sense?
Yes, and now a dumb question. Is the ETA symbol part of the typical Office, like it's going to be in Word, or how are we, like, I've just never seen that. Is that going to be an insert symbol, or we're just using an N and trying to fake it?
You can just type out ETA with a 2 if you want to.
Okay.
But yes, it is in the alphabet for symbols. So if you go to insert, symbol, it should be, you can probably go to like Arial or something. Find it, because what else are we gonna do today, right? You see, whoever sees it first gets 0 extra points on their grade.
You
Okay.
keep passing it, moving it.
You
I
keep
just saw
passing it. Yeah, you're going
Oh.
too fast. Go. Yeah.
There we go.
Found it. It's right by the H's. I always remember it being near the H's.
Thank you.
So yeah, no problem. So if you
There's
go
an-
to
you just-
Arial,
There's another one. That's the one I saw first,
Yeah,
more in the middle.
where you see it,
Keep going. Right.
right?
No,
Yeah.
that's not it. That's not it. I thought that was it. It has a little wonky thing to it. Not that one, the one next to the little ring on the row of the ends. That's where I was looking. But
That
that's
one?
not it. Yeah. That has a little
No,
curve on it.
That's a new. Yeah, it's a new. Greek letter, like new. But yeah. So just a couple of clicks and boom, H, right? AE or whatever that letter is, H or ETA. Okay. So yeah, it's there. Anyway, good question. All right. Everybody cool? Everybody good? Your turn. Who's ready to whine about stats?
Hey, yeah, we got that. I just want to say one thing. When it comes to replaying your videos,
You're muted.
What's that, Chris? Sorry, we can't.
Chris, you're
He
muted.
muted. He did it. Don't act like she muted herself.
I didn't know. That's so
When one of us is suddenly not talking, you can pretty much assume it's him. Not let we're just that dumb and muted ourselves mid
She's just about to
conversation.
say, when it comes to reviewing your videos, I was like, I don't want to know what she's about to say. I'm just
She's
gonna
talking about the
mute
peanut butter and jelly sandwich incident, probably.
I mean, I have to like hit slow down to watch the steps because like I'm having to look back at my screen, so the whole back and forth piece, or just while you went through steps, what was that, step 5, I think, or 3, whatever you were going through, and this for the
Eight.
SPSS. No, yeah, I didn't see all the clicks and stuff. I mean, I was watching you, but I was also trying to open up, because at first I thought we were going to walk. You wanted us to do the class IQ one with you. So I was trying to get it all
Okay.
open. So I missed some of this.
Okay. Yeah, you
But-
can or you don't have to. Yeah. It's this.
Is this
I'll be
the-
honest
this
with
is
you,
the
a
first-
lot-
Hmm?
Go ahead.
Is this the first SPSS step? Is this where descriptives was? Yeah, this is where descriptives.
It's actually under options. I need to put that screenshot here, the options one. Yeah, I'll add it back.
So what was the step you just showed before that?
5.
I thought you just
Oh.
clicked. Oh, it's next.
I'm not
Uh-oh.
sure what you're saying.
Uh-uh.
I'm going backwards. I'm just gonna go backwards.
Okay,
Tell me when it's on,
it froze for me. That step right there, that's analyze, compare means. That's you clicked on it when you did it live. It was faster than. Okay, I'm good. I
Well,
think
yeah.
I'm
Yeah, I do
done it
go
a billion
fast.
times.
All right. So let's get back to our wine. Who's ready to wine? So let's whine about stats. I did not misspell the word. Okay? It's a pun. You know what that is? Pun.
I'm so glad
Thank
I
you, Kara,
didn't
for the
say
laugh.
there should be an H. Well, I was like, that shouldn't have an H in it.
So I found sommelier ratings and prices of wines across the world. we're going to focus today's example on wines from California. And I'm going to go ahead and give you a heads up. Your homework's going to be on wines of Oregon, which are my favorite wines from the Willamette Valley. So yes, Kara, I guess that was not a nod to your location. But nonetheless, are average wine ratings different between the various regions that produce wine in California?
Okay.
How many regions do you think produce wine in California?
God.
8.
Jody,
Isn't it
did you
about
choose?
3 or 4? Isn't it Napa Valley, Sonoma Valley? Oh, okay. Well, that's, I only got one of them right.
Yeah, the one that most people know is Sonoma, and Napa, which is 2, 3, 4, 5, 6, 7. Yeah. Anyway, so yes, are there differences between these regions and the wine ratings as an average wine rating, right? So what we're going to do is let you do it. Okay. Did you get a SPSS file? Did you get the Excel file?
Excel.
Excel. I'm so mean. Gosh, I'm mean. It's a pretty big file, y'all. Really big file. And I'm only concentrating your attention on a state because it's a lot of data in here, right? So let's look at it for a second. Let's take a look at these variables. First one's an ID, then a country. Descriptions are nice. Designation, points. Points is what I'm calling the rating, sorry. Points are ratings. Price is price. Province is where you'll want to select data in SPSS that equals California, okay? And just as a quick reminder on how to do that, I will show
Like cases.
you. Select cases. You walk me through it, Chris.
Oh God. Okay. Select cases.
Data, select cases.
And then you're gonna if condition, to click on that and click on if, oh God, I forgot what you said we're doing. Okay, if that's, and I don't remember, what are we trying to pick? If, California, province.
Yeah.
Okay, so province equals California.
How do we type California? This is important, y'all.
Do we have a region number there? I don't know.
Nope.
Oh,
No.
less than 8
Nope.
characters.
Because we are picking a actual text label, you do a single quote,
Oh,
type it out, right? California, single quote, and this will filter only for those text labels that equal California. If you have a label in here that says California space, this is why data cleanliness is so important, y'all. But make sure that you say California, single quote, California, single quote, and hit continue and okay. And then come back to your data view and notice that there's a lot of these lines marking out these fields, except for 1, 17, 20, 21, right? You see all that? Okay. Those are our California.
But before you go, is there a choice? Because I remember I did select cases once before, and it just showed me what was true, not what wasn't. So I kept looking. I was like, oh my gosh, and only because I noticed the number. Like, was there a choice to select that?
Province.
No, I know how to get there, but I'm saying so that it doesn't show the strike throughs.
I don't know what you mean by doesn't show the strike throughs.
So when you go back to the data,
you're only seeing the California ones and you're not seeing all the other stuff because it's confusing.
Oh, you can sort. No, not really. Not in this one. Sorry. Too big.
Oh,
Too many values.
okay. I thought there was
Yeah.
it might be in 28. I don't know, because I swear that I'm gonna look and see.
No,
Okay.
that's what it does right now.
Do it
When I
after
just did that.
class. What's that, Kara?
No, I was just gonna say what Chris is talking about is what happened when I put that select case on. It's
Mhm.
only, it hides everything that's not California.
Okay. Okay. Yeah.
God.
yeah.
Well, hey,
It's just
my
the new
version doesn't
version.
do that.
Yeah.
Sorry, I'm old school. So
I just was making sure we weren't missing a checkbox. That's all. Thank you.
yeah, no problem. So what I want you to do, right? Select cases for California, but then your predictor variable, your factor, your independent variable, is going to be region 2. Okay, this is the one that has all the California regions displayed in it, right? We've got Central Coast, all that kind of stuff. And then you're going to run your ANOVA and fill in these blanks. Do y'all want to go into a breakout, or do you just want to stay here and I'll like turn off the audio or something so y'all can talk, but I just won't listen. How about that?
No, put us in a breakout, please. That way we, please. That gives you some alone time.
I
If we
am
were-
alone.
I know, but like to work on your job or something.
This is my job.
Some of y'all could jump in here and help me out.
We are by saying nothing.
Thanks, thanks. Okay, before I join this room, am I the only person who's going to be in here? Okay, no.
Okay. All right. So recode, transform, recode into different variables.
Oh yeah.
And so you would pull under here region 2. Or no,
Mhm. It was, yeah, 2 was,
and yeah, region 2, and you'd have to have your list. So go ahead and pull open your Excel file, do a pivot table, hit OK. It'll take a sec. Under province, into the filter, select, and then type Oregon. Take off Washington, Oregon, just Oregon, and then bring region 2 down, and you have 3 regions. That's going to be a lot easier to talk about post hoc tests, don't you think?
yes, thank you.
And trust me, Kara. Yeah, and trust me, Kara. I know that there's like 8 regions or 7 regions of Oregon. I did Google the maps earlier, but I decided to play nice tonight. And you've got Eastern Oregon, Southern Oregon, and Willamette Valley. Okay, so maybe because you've already got data coded under the region code of 0 through 8, go ahead and do 10, 11, and 12. Right? You don't want to put 1, 2, 3 here, because that'll mix you up with the Central Valley, the Napa, you know what I'm saying? Because it's all in the same data set. Got it? Okay. And just to prove to you that I did history, search history, Oregon 7 regions, boom, there it is. So we got Central, Eastern, Mount Hood, Oregon Coast, Portland, Southern, Willamette. I chose the one I love,
Yes.
and then the others. So real data plus fake data equals fun. Okay. Or you can do this in SPSS, Chris. You can do the transform, recode into different variables. Or honestly, you can pull up province, filter for Oregon. Right. Hit OK, and filter for Eastern. Put a 11, whatever. Drag it all the way down. Right.
No, thank
However
you.
you want to do it.
That could be a long way. Well, you just
It's a
gave us,
long way.
showed us there. That's perfect. Thank you.
Okay, so no problem. All right, so there you go. It's not a live assignment yet. I'm gonna liven it up tonight or tomorrow. Okay, but nonetheless. In addition, I have been adding more TED Talks for you. So I added another one while y'all were in your thing. So why storytelling is more trustworthy than presenting data. The beauty of data visualization, because that's important. And then making data mean more through storytelling. Okay, here's your lab. It'll be live later. Okay.
Are we listening to all three or a choice? I mean, we might listen to all three, but we need to discuss only one.
I'm going to ask you to listen to 3 of the total. I'm probably going to put out between 5 and 7. I'm going to ask you
Gotcha.
to listen to 3. I'm going to ask you to respond to specific questions about all 3.
All right.
They're 15 minutes long. Okay. Or less. They're
Son
TED
can
Talks.
practice his listening and writing skills. I'm just kidding.
All right. Let's spend a little bit of time talking about your project presentation too. Remember, I told you last week that in this project, I'm going to have some stipulations in terms of what data analysis I'm going to allow, right? I don't want you just to get out there and do some descriptive statistics and a t-test, right? That's not good enough. You're beyond that. You're better than that. You're stronger, harder, better, faster, right? You're all those things and more, y'all. Y'all are fantastic. And you're ready. I know it. You're going to do great. About as positive as I get right there. But does this make sense? So you're going to do 2 different types of tests on data of your choosing through a data storytelling presentation. For test 1, you can go as simple as a correlation, a chi-square, or a t-test, or any test from test 2. Okay. So you can do an ANOVA and a logistic regression if you want to, right? I'm not preventing you from doing any of these 2 tests. But test 1, you can only use correlation, chi-square, or t-test. This is an or statement, right? In test 2, I expect at least one of your tests to be one of these 6 options, right? I'm not forcing you to do logistic regression, but like I did the first round. But the important thing to think about here, y'all, is you need to map out a path of why this test and then that test help you to explain something to someone, okay? I do not recommend you use exploratory factor analysis. There's no point in doing it here. We are not trying to reduce items. Okay.
So it's the same data set?
No, it doesn't have to be the same data set.
Okay.
Yeah.
But it still has to tell a story.
Yeah, it has to tell a story. So you want me to give you an example?
Oh.
All right.
Oh.
Let's talk about my wife. I wanted to make an appearance tonight, even though we weren't here. And I always like to talk about her when she's not here, right? But this is what we call Freytag's pyramid. Okay. Have y'all ever heard of Freytag? Generally, theater. He's attributed to theater, drama, right? This is the same structure that if you ever go to a Broadway show, you're going to watch this play out time and time again. And my wife hates me because when we do see shows, I'm the one that says, "Ooh, rising action. Here comes the climax," right? So what do we mean by these things? What do we mean by these things? Essentially, sorry, I'm not clicking. Hold on a sec. PowerPoint's being weird. Give me a second. Sorry.
I do remember this from 10th grade. 10th grade?
Yeah.
10th grade.
Exposition, right?
but I don't remember. Our teacher taught us the word, which I love to just say, which is denouement for the climax. Or here's the aha moment.
All right, let's make sure. Sorry, I'm looking at everything right now. All right, sorry. All right, so there we go. Here we go now. That's better. Sorry, it wasn't doing it easy. Can you see it now?
Oh, there we go.
All
Yep.
right. Yep. So there we go. Oops, too much. All right. Boom, boom, boom. Vertex pyramid. This is essentially the way most stories are told, generally, right? We've got kind of the exposition, which I don't know why exposition is all jacked up. There's generally not that there. This is more so, exposition is when you find out about the setting, right, and characters. This thing real fast. All right, there we go. And appreciate y'all's patience with me tonight. This is what happens when you do way too much all the time. All right. So in the very beginning, we learned about where we are, what we are, who is who, right? And then slowly, sometimes but surely, we start to feel tension, like maybe some character came onto the scene and all of a sudden, like you feel like the tension of the room, right? You feel the tension with whatever, storyline it is. Maybe it's Romeo and Juliet and they're told, hey, no, you cannot be star-crossed lovers, right? You have to stay away because we're not friends with that family. And then, of course, the climax, which is where a turning point appears and something changes. And then generally there's a section called falling action, which is where conclusions, things start to line up. And then, of course, the story ends, right? So easy peasy. Let's talk about Delaney. Ready? Maybe this will work. Hopefully it'll work, all right? So this is a true story, y'all. True story. I can't remember if I told you the story or not. If I have, just listen, okay? But Delaney is in her 30s. She's a 30-year-old woman. She's an adult. She's been working full time for more than a decade. But the more and more she thinks about where she is and what she's doing, she really wants to go back and finish her degree because she sees on so many job postings, bachelor's degree required, right? She's got her associate's degree. We met, we got married, and now that we're settled here in Little Rock and I've been here for 2 years, she says, I think I'm ready. Every night I can come home and we can maybe do a class a semester, whatever. So I talked to her about it and she says, I think I'm going to go take a look at the online application, figure it out. When she went to college, it was a paper application. I think it was at a college fair. I don't even think there was a fee associated with it. And now it's an online application process, no person there to talk her through it. And because she's transferring in, and she's not transferring in from a college here in Arkansas, she's noticing that there are some things that they're asking for that are just kind of different, weird, whatever, because she's, got her associate's degree, but there are some things that, just aren't falling into place. So then the admission system tells her that she requires documents that she doesn't think are needed, like a high school transcript and ACT scores. 30 plus years old, been out of high school for 12 years at this point, right? But yet the system's saying missing high school transcript, missing ACT scores. She's very frustrated at this point. She contacts the admissions department and explains the situation. And at this point, the admissions team realizes that there's really something wrong with the system. And who knows how many people have actually gotten stopped at this point that have wanted to be transfers into this institution, but never submitted a transcript and never hear anything back from the admissions team saying why they haven't been processed. So the admissions team now realizes that this process is really cumbersome and is working to reduce that burden. And guess what happened next? Delaney enrolls. And that's her smiling face. Ta-da. End of story. Okay. She's actually got, hold on, let me see if I can show you the actual photo here. This is hilarious. You're going to love it. Nope, it won't show you. Okay. The actual photo is let's see if I can find it here.
I'm not loving how the admissions team is the villain in this tale. Poor Delaney.
She's got ice cream. That's what she's happy about.
Ice cream.
Yeah. Y'all see that?
Yes.
No. Yeah. It's a good smiling picture of her. Anyway. So Jody, yes. Jody, thank you. This story was sponsored by Jody, right? She works in admissions. Jody.
Yes.
Did anybody feel empathy for Delaney in this story? Where did you feel empathy?
When the evil admissions department was not going to work with her to allow her to enter school.
No one felt empathy at the first part of the rising action, only here?
No,
Jody?
you're right. Yeah.
At overwhelm.
At overwhelmed.
At overwhelmed. Yeah. How did this make you feel? This very first sentence.
Relatable.
Okay, so you can relate to that.
Mm-hmm.
Yeah. Did you say something?
No, I was like, that's an awesome goal. I felt, like top notch way to go.
Yeah, so this is a true story. They asked her, she had a thing in her admissions packet that was preventing her from applying to this school because she didn't submit her high school transcripts. As a college graduate with an associate's degree, it was the most screwed up thing, in all honesty. Like, how does someone not notice that, right? No offense, Jody. Check to make sure your processes are good, Jody.
I just want to say I work for a graduate program. We do not require high school transcripts. I want to put that out there. We only require college transcripts.
Now, what do you say, Chris?
Do college applications ask for your date of birth?
Yes.
Yes.
Yeah, see, they can that's an easy workaround. They can put the date of birth, figure a certain amount of years. If it's less than or more than, then it can automatically skip you to the next question.
No, we cannot, because remember, if she went straight from high school to work, she never had entered college. If she was a first-time in college student, they really would need her high school transcripts to prove that she graduated from high school.
Correct.
And they would need her ACT scores or SAT scores to place her out of what we call remediation. So I get why they ask for it, but they don't need to ask for it from someone who doesn't have to be remediated or is just trying to finish their bachelor's degree, right? So here's the next step. This is important, y'all. So pay attention right now. Ready? Where can I incorporate data analysis into my story? Notice I didn't, but where can I?
Following action.
Oh, how about good guess, Chris. How about rising action first? Why don't I do a t-test on data using first-time students versus transfers, average number of days to be admitted to the institution? Remember, I told you her application sat there from start to completion, took more than 2 weeks. Wouldn't that be interesting if I said, and y'all, this whole admission system, requiring documents, I found that when I looked at the number of days on average that first-time students versus transfers, that transfers had a much higher average number of days, probably, up to 2 weeks or something like that, right? Make sense? One test done. Okay. Second test, Chris, where did you say?
The following action.
Yeah, why don't we think about the likelihood of non-residents or non-in-state, right? She's coming from an out-of-state institution, out-of-state enrollment. Why don't we look at the likelihood of those non-in-state transfer applicants actually enrolling, because their requirements in Mississippi were different than Arkansas, and that was part of the hiccups. Is that they were going through and treating her like she was from in-state the whole time, and she wasn't. So why don't we measure the likelihood of this particular group of students, their likelihood of actually enrolling in this institution? Okay, does that make sense, y'all? Data storytelling, putting numbers where you need them, not throwing a bunch of numbers at you expecting you to remember them. Okay. So really, when I say data storytelling, it's a mixture of three things: data science, data visualization, and the narrative itself. I just gave you an example of a narrative. The data science is what we talked about after that, right? The t-test, the logistic regression. How do I make it memorable to you? Is I need to trigger the other part of your brain that sees things. You listened, right? And you felt empathy, right? And you analyzed, right? But now I need to do a little bit more to that story to just make it pop and help you visualize this issue, right? Okay. So those three things, and right there in the middle is what makes us act. So thank you for paying attention to that. That's just our quick intro to data storytelling. We'll talk more about it next week. Does that help you at least kind of frame what we're doing in this second project presentation?